Hey there. So today I want to give a talk on this development, this laser weighting robotics and for sustainable farming. First of all, I'm a assistant professor at Middle Tennessee State University. I'm working on in mechatronics engineering department, and because I work in this engineering department, I need to work on a lot of developing tools, mostly robotics, for farming. Before that, let me introduce you a little bit about the robotics I've been working on. I've been working on quite a few different robotics, including today's topic, mostly laser weight control robotics. I will also work on, have been working on the other robotics as well, including, for example, irrigation robot. Maybe we can talk in the future. We work on the very actively. Actually, almost done, by the way. That robot is also for sustainable farming. Actually, is able to performing smart irrigation. So I involve a lot of students work on that. I also work on mode control robotics. So for example, if we do strawberry control, right? We use UVC kind of clean energy, this non-chemical based approach for control this strawberry mold. And this is another robotics work on this laser based weight control robotics. So I will proceed to the presentation here.
Yeah, thank you.
Perfect. And so let's give you a little bit like an introduction here. So the food production overall in the world has to be, increase a lot. 70% food increase should be by 2050, to feed our almost 10 billion population worldwide. And however, the crop yield loss is very significant due to weight. It's as high as 32% globally. The loss due to weight is actually higher than the pest as well as the pathogens. And so in cotton, corn, and soybean, the loss actually maybe go to 1 billion per year. There's a few different non-chemical based approach for weed control. The first approach is really about soil, right? Crops and including, soil cultivation, right? Mostly me use mechanical tools for cutting the weight. Other tool including, for example, crop rotation and crop and cultivars. So specifically, including you rotate the different crops for for example, you do not want to planting the soybean forever, neither you want planting the corns forever. Rather, you plant the soybeans and the corns in a rotation fashion. More and more importantly, and people start to start using crop cultivars. For example, after certain like a season, you are planting different crops and to suppress the weight, which is very effective and also pretty low cost. And using the crop cultivars, which is showing the third picture here, and not only able to suppress weight, also able to bring nutrition and to the soil. Actually, it is a win-win situation. Sorry. Other technique involved is is mechanical based mostly. For example, we can use a hose, we can use harrows, we can use tins, we can use brass waders. This one here, actually, I just talk about, I'm born from like a blacksmith family, and my father is ever since 15 years old. My father was a blacksmith, and he worked until like 65 years old, and blacksmith. He was getting a little bit disease that he don't feel well by the time he was 65 years old, and he stopped there. But he was not totally stopped, right? Professionally, he worked about 50 years as blacksmith. I was grew up from a blacksmith family. And my father make a lot of these tools. My father make probably not this tool here. Every other tools. That's why I can afford my college because my father make tons of this kind of like welding tools. Ironically, I was making like robotics, similar to what he was making when he was in his peak time, like probably like 30 years ago, when he was peaking time making a lot of mechanical tools. I had to give him a lot of credits. And because today I'm making this automated like a weight control, the inspiration really from him when I was like elementary school, middle school, 10 years old, like 13 years old, when him see him making so many these kind of tools. In my father's time, he probably making thousands these kind of tools. I'm not sure 10,000, maybe even more than 10,000, maybe 20,000, all by hand. So he made these tools all by hand, by the way. And by the time I was in elementary school, middle school, most farmers still using this kind of tool for weight control. By the time I went to college, nobody using, very little people, farmers using this tool anymore. And they started to use spray, chemical sprays. And unfortunately, a lot of farmers got trouble using chemical sprays. Actually, myself got trouble as well. And one time I was using chemical sprays, I got toxicated by this chemical sprays. And that's not even farming. I was doing gardening myself, and that's back to 10 years ago, I think. I had a lot of memory this mechanical tools and which do with control. I really enjoy it, and maybe in my next project, go back to mechanical tools. And there's other tools, beside the mechanical tools, and so we use also thermal weight management. The thermal weight management, including mostly the like flamers, and also using this commercial one, they use infrared light. Actually, by the way, I'm also working on this as well. I'm not only working on laser-based with control, I'm also working on the light-based, mostly LED-based with control. I also work sorry, I did not only work on this. I did not work on this like this steaming-based control. I neither work on microwave control. I neither work on solarization. I thought this interesting, but they have own drawback. For example, microwave-based control is very energy intensive, and the flamers is not precise. I have experience. I work on it actually. I actually work on it and pretty actively even right now actually. LED based working, but the effect not immediate sometimes. It take time. Solarization I think working well, but maybe in my next project. Today I'll focus, however, on laser based with control here. The reason I like laser-based with control because myself, as I'm a very really engineering background, so I got a pretty good opportunity to work on laser in last 10 years. So initially, of course, I did not work on this weight control, right? I work on lasers, low power laser, high power laser, and for other different projects. But of course, there's a big benefit working on use laser for weight control. The benefits is obvious, is high precision, right? You can become very energy efficient, so you can localize particular to weight. Let's quickly going through the development process. This is pretty much engineering driven like a process. We starting from this project, we started project about 2022, but 3 years ago. From here, I have to acknowledge, give a thank you to our sponsor is Sayer. Sayer support me a lot. I think I'm really appreciated. Without them, we cannot get today. We make steady progress in the last 3 years. Of course, there are a lot of setback. The major setback for this project to happen is because we work on very limited budget, extremely little budget actually. But this budget is really difficult. So we have to calculate extremely carefully to not waste even single dollar. Even sometimes we calculate to the like 50 cents to budget in materials. And that's what sometimes we just little bit thing here we cannot do, and that's one thing. Second setback is really about the labor. um, I had to involve a lot of students, work on this project. I think excited, right? Sometimes students have no experience. I had to work with them very closely to make sure this thing happen. And sometimes work with them until midnight and to make sure they understand. We even work together to figure out how to design the part and manufacture parts. Let me go through quickly. So this one here, this is the part we designed from scratch, and the wheel assembly as well. The frame here, we all designed 3D CAD here. So these are the mechanical parts we designed. So this is the panel we designed here, and this is a 3D CAD modeling we designed. So we have 3D CAD modeling and use mostly SolidWorks. So we designed these frames, all the different parts. Actually, all the parts we designed from like pretty much from scratch. This is internal and this is from the look. Internally here you can see the lasers. We can see the like laser steering control here. We had all the electronics, computers here. Of course, we're still in the prototyping phase. Because we're in the prototyping phase, and we are a little bit messy, but it works, right? It works. And we will clean. We will make it a little bit cleaner. We can make it look more organized. But anyhow, I think this robot is able to travel around different terrains, and we can travel farms and without a big problem here. So this is our like videos. Let me play video for you. This video shows you this robotics travel around the farms. Actually, we use pretty big tires to make sure this one can travel around like tough terrains. So we have like a small camera in front for navigation. This one actually we're not quite ready for fully self-driving, and we're almost ready, I believe, for fully self-driving. We can talk a little bit more on that as well. So it can travel around different farms, and so to do like this. So and also here is we have software here, and this software designed to be very friendly. The way the friendly is so we have little button here. Actually, we don't even have too much buttons. We only have sliders here. So the farmers can control the like intensity. This is like the laser, and also the farmers can this one will be working the phone as well. So farmer can see that can see real time the way to control stuff. Also farmer can emergency stop button to stop lasers if anything going wrong. This is software instructions. Actually, ask students. Students actually made the instructions, and the farmers can use it.
This is a
We make better instructions.
for our laser weed control. As you can see, we have a safety delay up top in seconds. We have our laser energy, 0 to 254. And we have the duration of the laser. Let's put this up for testing purposes. And laser is off right now. We are being controlled by a game controller. And when we turn the laser on, we can see in the camera, those are the two lasers. And we have complete control over where we want them to go. I'll keep them on the center block just so we don't mess with the floors. But when it is time, both of those points of the laser will get centered on the center of the reed. The energy of our laser will be maxed out to in order it to actually kill a weed. Then when we turn it on, It's pretty bright, pretty fast.
So you see energy got intensified, right? So we can adjust it energy of laser.
There you have it. This is our GUI.
Right. Yeah. So we probably make a better video to make it more friendly for farmers. We have some results here, right? So I guess we can show you here, and we can play some like results. And so here I can play a couple videos to see what's the effect. It's pretty fast. So laser burn here. So we can burn that. Okay. Let me put other videos here. Do this here. Right. Pretty quick actually. Right. So now the ones. Let's go here. Right. And the other ones here. Right. Great. Yeah. So so it's zapped them, right? Pretty effective, actually. Right. Great. And so we have the ones as well here. Let's see. Right. See, pretty precise and pretty quick, actually. All right. Great. I think that's pretty much end of my talk. Thank you.
Well, thank you so much, Dr. Zhang. I really enjoyed learning about how engineering can be combined to help with IPM. So this is really cool. And I love the blue flame.
Yeah, they definitely works. I I enjoy them as well, right? So we can bring back just enjoy that part, I guess, right? Just like maybe take a look couple of them, I guess, right? Yeah, yeah, right.
Um, just a couple reminders. If anyone has any questions, please go ahead and add them into the Q&A at the bottom of your Zoom screen. And also, Dr. Zhang, if you could, when you're done with this video, could you put the QR code back up?
Absolutely.
The QR code is for any certified crop advisors that are looking for CEU credits for this live presentation. So you can go ahead and scan that and get your credits. And I do have a question, Dr. Zhang, and then we'll open it up to the rest of the group. Can this robot only be used in flat areas? And like how much slope could it handle?
Oh yeah, so we have been testing this robot here, right? So this robot is actually can travel like the slope. I think we test about like anywhere around like 35 degree and ish, right? And 25 35 degrees, that's fine. And so it is actually, if you look at this one here, it is able to walk around this like it's able to the pretty big tire. So actually the motor is pretty huge motor, by the way. So
Nice.
yeah, it has a lot of force to to go like pretty tough terrain, I think.
Great. Yeah, thanks.
Yeah.
Another question, how does the robot recognize the weed?
Yes, that's excellent question. So here is a, you can see here, this one here is so we have camera, right? Where we can see everything down here. Actually, we have like a camera, I believe, where the camera should be in this region. So the camera can see. So we use a wide angle camera. So the camera can see entire like down surface. Actually, this one here, what you see on the screen here is what under what's under this robot. Actually, we use like almost like a concrete center block for testing because this laser very powerful, and so only concrete can resist this. And this laser even powerful enough to melt the concrete actually. So we cannot turn on laser too long, otherwise melt the concrete. So yes, yeah, it is. So actually, we can see everything on the here. We have one student working on like use machine learning, mostly deep learning, to recognize weight and I think accuracy wise, accuracy wise, we got about 80% accuracy right now. I'm still not quite happy for 80% accuracy, and I think we can even reaching to we can even reaching to yes, thank you. We can even reaching to like maybe even 90%. We're working pretty hard using like uh, we can use like a machine learning model like we initially try YOLO model. The YOLO model work probably initially out of the box. YOLO model, pre-trained model working around 60%. We did quite a bit like a fine tuning. We got 80%. And right now we try to use more like a self called self supervised learning. We utilize a very large scale data set, mostly downloaded from online. We also prepare to collect our own data set actually, and as well, so and hopefully we can eventually, hopefully by the summertime, we can maybe reaching to 90%, at least 90, even more than 90,
Yeah, that sounds awesome. Thank you. Uh,
Great.
you say the laser's really powerful. So how long does it take to kill a weed? And are there any size limitations to the weed?
Yes,
Yeah.
that's a great point. And the laser, I think, it is able to kill the weight. We can count here actually. Let's count together. Right. So if the laser on, right? Let's count here. You can hear the sound. The laser start to raising power until the laser after here. Here the trigger is, you can see the click, right? That's trigger. You can see it's starting to trigger until trigger finish. That's how long. Let's count together. You can hear, right? The
Hmm.
click. The click sound is what Brady. Brady is really the man behind the scene. But Brady cannot visit me today. I mean, we are a couple students work together. Brady is one did quite a big contribution. So here is you can let's count. Yes, almost immediate. He click
Yeah,
on it, I should burn it actually. So
cool.
yeah, from click to burn, we cannot feel too much time actually. Yeah, I think the size, the weight, it just hard to say the size. I guess maybe inch, 2 inch. So I guess yeah,
Okay,
yeah.
that's helpful to know.
Yeah.
Um, is this system only working on certain weed species, or do you expect it to work for all?
I think the species wise, Uh, we did not do thorough tests yet. Actually, this summertime we do more thorough test. Maybe go to farm, maybe go to the farmer's house. I mean, not house, sorry. Go to farm. Go to farm to test around different species. I think we can test a different wide range of species. According to theory, I think according to theory, at least literature-wise, I'm reading. Uh, I think some way they may be different from others. Some way they a bit tough to kill, because they're thicker. The way like the leaf a little bit thicker. The stem a little bit thicker as well. So I think in nature the laser weight-based control is designed to kill like a smaller weight size. For larger weight size, it can be tough,
Okay,
and maybe mechanical based approach better.
yep, that makes sense for now, especially.
Yeah.
Can this robot be sped up and scaled to remotely weed large acres, like 80 acres of row crop fields?
Yeah, I think so. That's our design goal here. And this robot here, actually, the batteries, by now, right? Of course, our robot are very low cost. Actually, our robot is not the first one. There are multiple other one, like most prototyping. Of course, there's a more commercial one. You probably heard about that. The commercial one, I think, called Carbon Robotics. Common robotics, I think they sell $1 million. I think, of course, we are research, we're not designed to sell, right? So, I mean, all ones, even the base one here, where the battery can sustain you probably, we did running outside, I think at least an hour, 2 hours. I think anywhere between hour to 2 hours. We did not run long test, but based on the current performance, I think about anywhere between. I think I could very comfortably say maybe an hour and a half, I guess. And for now, and for if we increase the number of batteries, one battery costing probably, let's say, the battery we bought maybe $150. We can put maybe 3 more batteries, and this power, this robotics able to carry at least another, based on the motor we have, we can carry at least maybe another 300 pounds, and to at least to walk on the flat terrains. If we run very tough terrains, right? Maybe
Yeah.
another maybe 50 to 100 pounds. And we can at least maybe adding another 2 to 3 batteries. In that case, I can say this robotic can walk outside maybe 4 to 5 hours. Based on the speed, we can estimate here, right? Like this speed here, you can estimate, I mean, 4 to 5 hours can do a lot of different terrains, right? So of course, when to kill options, you have to slow down a little bit. This doesn't involve kill here. If kill,
Mhm.
right, probably half speed, if that is kill,
Sure.
assume a software 90%, right? If a software not 90%, we have to slow down a little bit to make sure we kill multiple times, to make sure high confidence, right? But I think, our goal here probably half speed this speed, and to travel around these terrains to 4 to 5 hours. We probably 3 to 4 batteries, and that's the goal here. I think 8 acres maybe doable. 8 acres, and you probably have to maybe store like 5 6 batteries, costing maybe $600 maybe each. You have to store batteries. And
Yeah.
we can design a software, make sure, it come back. Your battery low, come back, and swap batteries, let it go again.
So are you saying the batteries are rechargeable?
Yes, all the
Okay.
batteries are rechargeable batteries.
Okay. That's great. Okay, next question. Is this robot fully automated, or are there plans to make it fully automated? Or does
So
it?
far, yes, great questions. Thank you. So we're not fully automated yet, and we still like our manual control right now. But software, actually, we have a person developing software, fully navigation. We have demo, but we have not this robot. We work on 4 or 5 different robots at the same time. Actually, we another robot already, I think probably 80% self driving almost. That's why we use one camera in the front and to do like to recognize the obstacles. We have GPS already actually. We have GPS. It's a GPS based. So what the farmers do, like they draw waypoints on the map, and it just follow waypoints, and it will automatically stop if there is a big rock in front, or I mean, if the like something going on in the front, it can stop. You can see the little. Actually, today, Bradley working in the lab. Actually, we making another housing to cover this camera. This camera not waterproof, so we make sure this camera protected. So we make it called sensor bars and on top here. So we make it waterproof. Yes.
Great. A couple people are curious, is there any plans to combine the laser technology with drones?
Oh, that's a great question. By the way, research-wise, I did not work on drone yet, much yet, but we do work on drone in my class. We actually fly big drones. We fly actually like almost like a 2 foot long drone, by the way. So that one designed for a smart irrigation project, not for this one. I think that there's potential, I mean, there's definitely potential. We use drones to survey the entire land, right? And we may be even counting the how many how severe the weight, right? Do some surveys first, right? And and then we can decide like the kill strategy. Actually, Brady today working outside, so there's actually small tricks kill the weight. The tricks is the weight control is not straightforward. Just shine a light on it. Actually, you have to find some particular patterns to kill the weight. Yeah. So if we know the weight types, I think that probably helpful for make optimal kill to save the battery. Yeah, that definitely there's room to work with drones.
Okay, there's one more question. We'll see if you have an answer for this one. What's the long-term efficacy of laser treated weeds?
You mean long-term efficacy, right?
I think so.
Long-term, I think long-term efficacy is here. I think this one here, in order to make it practical, farmers I think typically have to kill this weight like a relatively lower in a smaller weight. Once they grow up, I believe it become hard to kill it. This laser-based approach will be not very viable to control bigger weight. I think so. That's probably for long term is maybe part of plan. One farmer plan out if they use this one here, that yeah, really be like on alert. When weight be smaller, just kill them early. Number one. Another long term is this robot designed to be low cost, right? Low cost. And so farmer don't have to be like spend like $1 million to buy this one here. I mean, affordable, I believe. I believe the investment is worthwhile. I mean, you don't use chemicals, right? It's better for the soil, right? And if you don't use chemicals, it's also probably good for farmers' health and as well.
Yeah.
Yeah. So I think that health may be long-term concern to use this approach, I think.
Well, great. Fantastic job today, and thank you so much for joining us. For everyone else, this Pests in Progress webinar is available from the North Central IPM Center. We're one of 4 regional IPM centers supported by USDA NIFA's Crop Protection and Pest Management Regional Coordination Program. Our mission is to coordinate IPM across the region by sharing and promoting IPM research, extension, and teaching activities. Our next webinar will be Wednesday, June 18th at 1:30 p.m. Eastern Time and 12:30 Central. The title of the presentation will be Integrating Long-Lasting Insecticide Netting into IPM Programs After Harvest by Dr. Rob Morrison. So thank you all for attending today and asking wonderful, interesting questions. We hope to see you next month.